This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Auth0 is the easiest and fastest way to implement authentication and authorization architectures into your apps and APIs. Allow your users to log in with username and password, social and enterprise identity providers such as Facebook, Twitter, AD, or Office 365, or without passwords using Slack or WhatsApp. Getting started is very easy. Use one of more than 40 SDKs and add a few lines of code. No credit card required. Get the free plan at auth0.io/SERadio. That's auth0.io/SERadio. Auth0 is trusted by developers at Atlassian, Mozilla, Optimizely, and Financial Times. Try it out at auth0.io/SERadio and get back time building core features.
For Software Engineering Radio, this is Edaena Salinas. Today I have with me Sachin Gadre. Sachin Gadre is VP of Product Management at Software AG. He's responsible for managing the hybrid integration platform, IoT, microservices, and API management. Prior to joining Software AG, Sachin worked with Accenture, where he worked on making IT strategy engagements in the high technology sector. Prior to Accenture, Sachin worked as a solutions architect at Bearing Point. Sachin Gadre, welcome to Software Engineering Radio.
Thanks. Thanks for inviting me for this chat regarding IoT.
Yes, today we will be talking about the Internet of Things and its architecture. The Internet of Things is also known as IoT, and it has enabled many new business models and applications. First, to understand what IoT is, what are some of those new applications and business models?
Yeah, so IoT stands for the Internet of Things, and it's really a concept about connecting any device to the Internet and to other connected devices. So you can think of IoT as a giant network of connected things and people, right? And what this is enabling businesses to do is to create new business models, as well as within their existing businesses, look for newer optimizations or newer efficiency improvements. So, for example, you could think of a product such as a factory machine or something. You can actually track the performance of the product in real time, and then can offer additional benefits like predictive maintenance services, such that even before the factory machine or the product in question can actually break down and cause a stoppage in production, you can go and fix it. So there is a number of such applications, and we are also seeing new business models being generated. So like, instead of selling a particular machine, you can rent out a machine, and then you can charge based on the usage of the machine. And this is all possible because of IoT.
You mentioned first, IoT is about connecting any device to the internet. What are some examples of those devices that you've seen that businesses are connecting to the internet?
I'm actually, the sky is the limit, because any device that can be connected will be connected, and you can certainly build applications. So in the consumer world, what we see is the Nest thermostat, which is a connected thermostat that allows you to monitor your home, monitor the temperature inside of your home. On the business to business side, we are working with customers which are providing connected car solutions, where they have built-in sensors in the cars, and they are tracking the driving habits of cars. We are also having customers where they are putting sensors within printers, so that they can track the performance of the printer, the toner quality, and if there is a mechanical breakdown, then they can detect that before the breakdown actually occurs. So those are some of the examples.
One thing that you mentioned at the beginning is IoT is about connecting any device to the internet. What are some of the challenges of connecting devices and creating IoT applications?
There have been many surveys that have been done on the challenges of IoT adoption. For example, the survey that comes to my mind was done by the Economist magazine. They have a Economist Intelligence Unit, which is a subsidiary that provides advisory services. So earlier this year, they took a survey and they found out that the top challenge for IoT adoption was the high cost of investment required in IoT infrastructure. The second challenge that they found was related to security and privacy concerns. Now, these challenges, they have been there for a while, and as far as the expensiveness of IoT infrastructure is concerned, I firmly believe that over a period of time, the cost of deploying IoT solutions will come down. In fact, Moore's law will eventually kick in and will bring down the cost of these IoT devices, as well as the sensors and chips. And finally, I truly believe that the devices will become more powerful and functional. So right now, when you look at the IoT investment model, you need to really look at what use cases you are going for and what are the benefits. And there are many use cases that we find where the cost of implementing the IoT solution is well worth the cost because the benefits are even greater. So that's where we are.
Just to confirm what you just said, you mentioned part of the cost is the sensors themselves and the devices.
Yeah, absolutely.
Okay.
So what happens is that over the last 5 to 10 years, we have seen the rise of the smartphone. As an example, a typical iPhone has 7 or 8 sensors. So what is happening is that as new devices come in, they have built-in sensors in them, and you can take advantage of those sensors. And because of the widespread use of smartphones, the price of these sensors is also coming down. So yeah, I mean, a part of the cost is in the sensors and the chips, but that is also coming down.
And through the Internet of Things network, which is these devices that are connected to it, they're exchanging data. What are the main industries that are adopting the Internet of Things?
Well, there is strong IoT adoption across all industries, but one industry that stands out is the manufacturing industry. In fact, this is an industry that I work with a lot, given that I work with Software AG, which is based out of Germany. In fact, in Germany, there is a term called as Industry 4.0, which is used to describe the fourth industrial revolution. So, Industry 4.0 is all about smart factories that use information and communication technologies to digitize their processes, and then they can reap huge benefits in the form of improved quality or increased efficiency and lower cost. And all of this is being possible through IoT. So, as an example, Software AG has just formed a joint venture called Adamos with 4 other manufacturing partners. And this joint venture is really about taking Software AG's cloud-based platform and then allowing these 4 partners to build IoT applications on that platform for their customers. In fact, Adamos stands for Adaptive Manufacturing Open Solutions. So we see manufacturing as a key area, but then there could be applications of that in healthcare. We have seen retail being a big adopter of IoT solutions. So there is a lot of industries that are coming over, but manufacturing is just the standout, just because of Industry 4.0 and other things.
And maybe also because of the impact in manufacturing, like lowering costs and things like that.
Absolutely. So lowering cost, improved efficiency, things like providing additional capabilities like predictive maintenance,
Yeah.
because it's all about trying to prevent the breakdown of machines and trying to fix the machine before the breakdown occurs.
Yeah, exactly. In the traditional way would be there's a factory, a machine stops working, then you call maintenance. They might even take the machine or come to repair it there. Whereas with this predictive way, you will know, oh, this machine might fail next week.
Absolutely.
So you plan ahead for that downtime.
Absolutely. That's exactly what is happening with predictive maintenance.
Let's talk about the types of objects more. What are, for example, good candidates to be connected in IoT? We talked about factory machines. Is there anything else that you consider a good candidate?
There are many examples of connected devices or machines in both the B2C and the B2B world. I talked about the Nest thermostat.
Yeah.
There has been this iconic button that came from Amazon that many brands are now integrating with. So you can have that button, which is actually kind of sticks to your refrigerator, and you can just press it to order things like your milk
Hmm.
or your detergent and things like that. But across our customer base, Software AG's customer base, we are seeing physical assets that includes factory machines, air compressors, printers,
Hmm.
being connected to power IoT use cases.
Hmm.
Those use cases, as I mentioned earlier, could be predictive maintenance, track and trace, and things of that nature. We are also having examples of a connected car or even windmills that are generating electricity from wind. They have sensors in them to make sure that they are operating optimally
Hmm.
and they are generating optimal amount of electricity.
Yeah.
So the choice of the object is really dependent upon the use case, and we see wide adoption across a number of these objects.
Hmm. What about the data that these devices are exchanging in the internet? What's an example of the data?
The data again depends upon the device that is being tracked in real time. So I will give you an example of Octo Telematics, which is a customer of ours. Now they have put sensors in over 15 million cars, and those sensors are sending data, and essentially Octo is tracking the driving habits of these drivers.
Hmm.
And they're collecting all the data. They are deriving insights in real time as well as via batch analytics. And then they are making these insights available to insurance companies
Hmm.
so that they can provide customized or personalized quotes to these drivers based on their driving habits.
Hmm.
We also have another example of a printing company that is tracking the status of the printers. They are tracking the status of the print quality as well as the toner levels, and then using that information to send maintenance crews out to those customers where the printers are located so that they can fix the printers before there is a mechanical breakdown.
Hmm.
Another interesting case that we have is of an air compressor company that actually change their business model. So, air compressors, these are devices that are used in constructing large buildings as well as houses and things like that. And typically, the construction company would buy these air compressors. And that basically means there is a huge upfront investment. And when you're not building anything, those compressors are not used. So the new business model is to rent out these air compressors, and using sensors that are built into the compressor, they can keep track of the amount of compressed air used per day, per hour, and then this company is able to charge their customers on a usage based way as opposed to just selling these machines outright. So again, this is a new business model for them, which is again powered by IoT. So there is a wide range of data that can be tracked.
Yes, and some of the ones you mentioned are the amount of air being compressed. In the case of the printer, the toner quality. For the Nest thermostat, I imagine is the temperature at various times of the day.
Absolutely.
What about the format of this data? Is there a standard of how this data has to be exchanged? For example, JSON, XML, or something like this?
Yeah, so there are multiple protocols for exchanging this data, and it really depends upon the device that is basically sending this data. For example, we have numerous protocols like MQTT, which is message queuing telemetry transport. This is a lightweight PubSub protocol for bandwidth constrained networks. We also have a REST based protocols. We have for certain devices we have OPC UA, which is a standard to integrate with some of the industrial equipment. There are many such protocols.
Hmm.
And as far as the data formats that are concerned, it could be a JSON format, which is typically used because, again, the size of the JSON payload is smaller. But in some cases, we have seen XML being exchanged as well. And then there are certain devices where there are certain device specific data formats that are being used.
Hmm.
Again, the whole idea is that you want to send the information without putting in a lot of padding in that information to increase the size. So you want to send the information over a bandwidth constrained network, and the whole idea is to make it as small as possible. So there are
Mhm.
multiple exchange formats.
What was the name of the first one that you mentioned? MQ.
TT, MQTT, T as in Tom, T as in Tom.
Okay. And it means message queue.
Message queuing telemetry transport,
Okay.
which is MQTT. Then there is a REST based protocol called COAP. And then there is OPC or OPC UA. These are all data protocol standards.
Earlier in the show, you briefly mentioned security in IoT. I want to talk about this a little bit more. With the Internet of Things, we're essentially building a world sized robot, some people say. What are some of the potential security threats that stand out?
Well, as I mentioned in the Economic Intelligence Unit survey, on the technical side, the topmost challenge was security and privacy.
Yeah.
Most of the IoT data originates from these connected devices and sensors that are outside of your network. So the attack surface for IoT is much higher than a traditional software application that is installed within your data center. So security plays a very important role in an IoT application. And there are a lot of ways by which an IoT application can be hacked. For example, you need to ensure that there is physical security, right? So whether it is your connected devices or sensors that are out in the field, they have proper security so that no one can access them using unauthorized credentials. Then there is network security. The data that is being transmitted back from these connected devices to your IoT application, it needs to be sent in a manner that it is secure. So using standards like secure sockets layer. Then there is application security. Your application that is receiving all this data, and one of the facets of an IoT application is that you will receive a large amount of data because you have tens of thousands of devices that you are tracking. And so as you start getting all this data, you have to make sure that your application is robust enough. And because it is being exposed to the internet, it can handle things like injection attacks like SQL injection or session stealing or even denial of service attacks. And then finally, you need good access control and authentication, not only at the device level, but also at the application level. So there are many layers of security that you need to worry about. And you need to make sure that you have the right kind of defenses built into each layer so that an IoT application can work without anyone causing any harm to it.
Yes, that's an interesting way of putting it. You mentioned there's a networks itself has to be secure. There's also the device and the application that's in the IoT device, right?
Absolutely. The application is both at the IoT end, meaning near to the devices, because you can have a device that is connecting to many of these sensors, but you can also have an application at the main IoT hub that is processing all that information. And both of these need to be protected.
And you also mentioned part of the risks might be not handling authentication correctly.
Yeah, so there was physical security, network security, application security, and then the final one was just access control. So making
Okay.
sure that you have proper authentication and authorization for IoT application, and you have fine-grained control over entitlements, so that different users get to do their jobs, but they are not given full access into the system.
Okay. Because that one reminded me yesterday, I think November 19, I saw Germany banned smart watches for kids because apparently some people could listen through the smartwatch. So I guess that might be related to that access control, right? Would this be a good example to illustrate access control?
Well, that would be more of a, how the physical security of that watch, as well
Hmm.
as the data that is now being
Okay.
accessible. So it is, I would say, it is more around the physical security and the network security rather than the access control themselves.
Okay. So access control might be then we have the machine from the factory connected. I should only have access to certain actions of the machine, or
Yeah, so the access control is more on the application side.
okay,
Okay, so it is on the IoT hub side.
okay,
So making sure that the right people get access to the functionality to control the devices as opposed to
I see.
just giving super user access to everyone.
Yeah, because some of these can be fatal or not so fatal. The ones that I've read about is somebody suddenly can decide to turn off the elevators from buildings and people end up being trapped there.
Yeah, absolutely. I'm going to talk. Yeah, there are numerous
Okay.
such IoT systems that have been hacked in the past.
Hmm.
So, for example, in the recent past, I think in last year or so, there was a distributed denial of service attack using IoT devices. So, in this case, what really happened was the devices that are out in the field, they were provisioned with their default user ID and password. So someone who did the provisioning, they did not even bother to change the default user ID and password. So hackers were able to, because these devices are accessible over the internet, hackers were able to ping that device and to get into that device and install a malware. In this case, this malware was called Mirai. And then this Mirai malware, what it did was it used all these devices to create a distributed denial of service attack that caused large portions of the internet to go down. Like Netflix was down, there was Twitter was also impacted. So this was a huge attack using IoT devices, unprotected IoT devices.
I see. And again, in the security space, are there some minimum security standards that have to be in place in an IoT system?
Yeah, absolutely. There are certain minimum security standards that have to be present for an IoT application. In fact, this area has not really been a focus area until recently when the US government created what is now called as the IoT Cybersecurity Improvement Act of 2017. And this proposed bill would require all devices to maintain certain minimum security standards so that they can even be purchased by federal government for their IoT applications.
Hmm.
So this is the first time that we are seeing a government acting and creating an act for some minimum security standards. And these minimum security standards, they make a lot of sense. For example, one of the goals of this act is that you have to remove the hard coded passwords, and for each device you need to have a separate credentials. Then you need to ensure that there is SSL being used for communication between devices and the IoT servers. And then there is also a provision to make sure that the IoT devices themselves are being patched on a regular basis so that they are secured against different forms of malware. And then the other thing is to maintain an accurate inventory of all the devices and to ensure that they are not being tampered. So it makes a lot of sense, and it's good to see that there is now an official act that is being discussed, and this proposed bill will make it almost mandatory. And I hope that this will be followed across the industry, not just by the federal government.
I want to switch gears now and talk about another area that you've worked on, which is cloud based IoT. Can you explain what cloud based IoT means?
Specifically, we mean by the cloud is that a cloud based IoT platform is a set of fully managed and integrated services that allow a customer to easily and securely connect, manage, and ingest IoT data from all of these connected devices. Now, once the data is ingested, the platform then can provide additional services to process this data, to analyze and visualize that data in real time. And finally, one of the highlights of an IoT platform is to not only analyze this data, but then also allow actions to be taken based on the insights gained from this data by implementing workflow based apps or by integrating this data with on-premises and cloud-based applications. So all of these capabilities, when they are present in the cloud, are offered as a fully managed and integrated services. That is what makes it a cloud-based IoT platform.
And for example, in actions, one thing that I can think of is if you have a room of servers and then you're monitoring the temperature, if the AC suddenly stops working, take an immediate action of turning off the machines, right?
Yeah. So, for example, in this case, your IoT application is in the cloud,
Mm-hmm.
but your AC is located in at your home.
Okay.
And one of the challenges that the AC is sending a continuous stream of data to the cloud-based IoT platform, but it is going over the internet. And as long as the internet is active, you can process the data and then you can turn off the AC or you can turn on the AC.
Mm-hmm.
But what happens if the internet is down?
Yeah.
Then you need the ability, your IoT platform needs the ability to do some local processing as well. So it really depends upon where and how much processing you want to do locally versus in the cloud.
Or you can even put the critical functionality to also work locally, I guess.
Absolutely. Yeah. That is the whole idea.
Mm-hmm. That's a great point.
Don't let security checks be a burden on your software deployment. Veracode Greenlight gives you secure coding feedback in seconds directly in your IDE. Try Veracode Greenlight for Eclipse free for 30 days and tap into Veracode's binary static analysis engine, delivering in-depth and accurate results to developers in just seconds. Request your trial of Greenlight for Eclipse today by visiting veracode.com/greenlight-trial. Not using Eclipse? Visit veracode.com/greenlight for information on Visual Studio and IntelliJ plugins.
Let's talk a little bit about the enterprise. One thing that I saw is Software AG works a lot with enterprises. So I'm wondering, what are the needs of an enterprise when they're starting to build an IoT application?
Okay, so an IoT application is quite complex, right? It has multiple
Mm-hmm.
moving parts, and the key requirements for any IoT application is device connectivity and management. For example, any IoT application is potentially going to integrate thousands of devices with different connectivity and management requirements. And then, of course, it has to integrate with those different devices or very proprietary protocols and standards. So that is something that is truly very important. Once these devices are connected and as the data starts flowing, then you need real-time data processing, because you need to make sense out of that data that is coming at you at a very fast pace and deliver insights within a matter of minutes or within a matter of seconds, actually. And then finally, you still need the ability to take actions on that data. So based on the insights that you have gained, you can then integrate that data. For example, let's say you are monitoring a factory machine and you realize that there is a problem with that machine and you need to order a new part, and then you also need to send the technician out to fix that machine. So what this means is that you need to first integrate with the ordering system, which might be an SAP ordering system. So you need that integration capability. Once you have ordered that part, then you need to, based on the delivery of the part or the shipment date associated with that part, then you need to schedule an appointment
Mm-hmm.
in your service management system so that you can actually have a physical person go and fix the machine. So there needs to be a lot of integration. And finally, you need to develop workflow based apps so that if there is any manual intervention that is required, then you can recognize that there are tasks, that manual tasks that need to be carried out, and you can assign it to the right person who can do those tasks. So there is a lot of moving parts. You need device connectivity management, you need enterprise and cloud integration, you need real time data processing, and you need workflow automation as well.
So are these the components of an IoT platform in general?
Absolutely. Any IoT platform, including Software AG's Cumulosity IoT platform,
Mm-hmm.
has these components. What we are seeing in the market is that there is no single vendor that can provide all of these components. What we have tried to do with Cumulosity IoT is we have bundled together best of breed capabilities in device connectivity and management, enterprise and cloud integration, API management, real time streaming analytic capabilities, as well as workflow automation. And then on top of that, we have put solution accelerators. And what I mean by solution accelerators is that these are use cases that we see very often being deployed by our customers, such as predictive maintenance. So we have gone above and beyond, and we have created pre-packaged templates
Mm-hmm.
so that when a customer is implementing an IoT app, they can just use the predictive maintenance templates, and they can gain from our experience in implementing such kind of applications at other customers, and they can get a head start and quickly build that application. So it is not just the product offerings, but also the templates and the industry experience that is part of the IoT platform.
Mm-hmm. So in this IoT platform that you describe, you mentioned there's a integration layer, also the workflow component. Is this platform structure also the IoT architecture? Just want to understand if I'm getting the terms correctly. So there's a IoT platform components, but we can also have an IoT architecture, or is it the same thing?
Yeah, so most of the components of that I mentioned earlier are part of the IoT architecture.
Mm-hmm.
Now it really depends upon, you don't need all of these components to kickstart or to build your first IoT application. I
Okay.
think you will start with something like device connectivity and management, and you need enterprise and cloud integration.
Mm-hmm.
Those are the most important components. You can bring the other components depending upon your requirements. So,
Mm-hmm.
for example, if you have tens of thousands of devices and you are getting a lot of data and you want to quickly gain some insights into that data, so that, let's say, you are monitoring a temperature of a nuclear power plant or something like that, and if the temperature is increasing, then you want to shut down that plant. And
Mm-hmm.
this particular thing is so time critical that you need to analyze the data in real time, and that's where you need streaming analytics. Whereas in some other cases, you don't care about taking decisions by the second. And at that time, you can possibly take all of that data and analyze it using a batch analytics layer, like a Hadoop.
Mm-hmm.
So it really
Yes.
depends upon your use cases. But I would say that certain components are, we almost see them all the time. And then certain other components you can bring in as per your requirements.
Okay. Let's talk about this a little bit more. So the way that you mentioned is there's a data source that consists of thousands of devices, and then you have a data processing layer, and there are two options. One that you mentioned is streaming analytics or in batch. Can you just describe in a little more detail what streaming analytics means?
Yeah, so streaming analytics is the ability to constantly do statistical analytics
Mm-hmm.
while on a stream of data. So this is stuff that is happening in real time, right? So you have a live streaming data, and streaming analytics allows for management, monitoring, and real time analytics of that live streaming data,
Mm-hmm.
versus batch analytics, which is not real time in nature. So
Yeah.
in this case, what happens is you want to do, let's say, historical analysis. So you want to take the data from for the last 1 month or the last 1 week or the last 1 year, and then you want to do number crunching on that to figure out trends across a large quantity of data.
Mm-hmm.
Whereas with streaming analytics, you want to calculate the trend within a small slice of time, typically less than a second or something like that. And again, there are use cases where, as I mentioned, if there are time critical use cases where you need to get that insight at that moment and then act on it, then you would choose a streaming analytics layer. If you're okay with doing historical or batch analysis, then you would just store all of that data in a Hadoop and then kind of do batch processing of that. So
Mm-hmm.
it really depends
Yeah.
upon your use cases. And both of them, actually, we are seeing that our customers are using both of them to figure out insights, because you get different insights from streaming analytics versus different insights from batch analytics.
So for the batch one, going back to an earlier example, I can think of the one about predicting if a machine at a factory will fail. You might want to look at how it's been behaving for the past 3 months or something like this, right?
So in this case, I would say that you would need streaming analytics. So for example,
Oh, okay.
well, it will be a combination. So what you can do
Okay.
is you can look at the past 3 months of data, and based on that, you can create a machine learning algorithm
Hmm.
and then apply that machine learning algorithm in real time in your streaming analytics layer. Because you do want to know if the machine is failing, then you do want to know as early as possible. You don't want to do this analysis after the fact, and then basically by that time the machine has already failed, because the value of the IoT application is to prevent that failure and to do predictive maintenance before the machine fails.
I see. And what would be one where it can be purely streaming analytics? Would this be more for critical scenarios like maybe a machine at a hospital or something like this?
Well, absolutely. Anything that
Hmm.
is time constrained. Now, again,
Okay.
streaming analytics is not a silver or a golden bullet. I mean, it all depends upon
Hmm.
the amount of data that you can process, and the analytics and the insights that you can get depends upon how many events are being pushed into the streaming analytics layer. So, if your event is a very tiny event, then you can process tens of millions of these events per second. Whereas if you have large events, and then these large events invoke like a Zementis scoring model, or maybe you need to update a database, or you need to look up a database, or you need to apply some business rules to identify trends or to identify insights in this data, then obviously you're doing a lot of processing within the streaming analytics layer, and therefore the ability to process your events is dramatically reduced. So in this case, you might see that you will be processing 1,000 events or so per second. So it is not uncommon. We see within our customer base, they are processing multiple thousands to tens of thousands of events per second.
Hmm.
But again, the ability to process these events depends upon the size of the event and the amount of processing, the rules that you are applying within the streaming analytics layer.
When I was researching for this interview, I saw that you've worked on building IoT applications, specifically also using microservices and APIs. And you were presenting this diagram where you talk about, in addition to the data sources layer and the data processing layer that we've been talking about, there's this notion of an enterprise integration layer. Can you explain what this layer does?
Yeah, the enterprise integration layer is a key requirement for any IoT application. And as I mentioned, the example where, let's say, you realize that a particular asset like a printer or a factory machine, let's say it is having a problem, and you need to order a part, or you need to schedule a service technician to go out and fix the machine. In this situation, you need to connect to backend data sources like
Mhm.
large applications like SAP, Oracle, and others. And in some cases, you might want to integrate with cloud-based apps as well. So this is where the enterprise integration layer, fulfills this key requirement.
Mhm.
So developers can write services to extract data from the source application, and then or can write data to a target application like an SAP ERP. And while doing so, the enterprise integration layer provides capabilities like transformations, validation, mapping, orchestration, things of that nature. So, an enterprise integration layer is key for any IoT application.
And what is the role of microservices in this layer?
Yeah, so microservices is a new architectural style for building the next generation of web scale applications. So we have been building applications for a long time now, and as far as the standard for doing integration architecture, it used to be some called as SOA, which is service oriented architecture, and this is all about building large grained services so that they can be reused within your IT enterprise portfolio. So SOA is all about reuse, whereas microservices, which is, I consider it as the next step in the evolution of the SOA architecture, they're all about agility and scalability. So reuse is a secondary concern in microservices, whereas agility and scalability are the topmost concerns.
Hmm.
So what we are seeing is that our customers are adopting this new architectural paradigm for building the next set of web or IoT or mobile applications. And this includes not just microservices, but it includes other technologies like containers, APIs, DevOps, events. And these technologies are interrelated with each other. So when you use microservices, typically you need to use DevOps
Hmm.
because that's what gives you the agility. And then you need to use containers and APIs. So all of these are technologies are related to each other, and these are the I consider them as the fundamental building blocks for the next microservices style architecture.
So you mentioned microservices are about agility and scalability. One thing that I think of in microservices is splitting the different areas. For example, you can have a microservice that deals with sign-ups. So if you have a product that requires people to sign up, you have a service for that, a microservice. And then you have other things to look up pictures or things like that. And that's how we can scale quickly because, for example, if your website becomes very popular, you are going to have to serve a lot more signups. So you can scale that microservice, right?
That's right.
It's something like this.
Yep.
Okay. In the concept of IoT, what's an analogous example? Like here, I'm talking about signups services, but in IoT, what is a service? What is it doing?
So at the end, an IoT application is made up of services, and
Okay.
it could be a service that is analyzing the data that is coming from the IoT devices.
Mm-hmm.
So the whole idea with microservices was that these are smaller grained or microservices that are independently deployable and scalable. So essentially what this is that if you want to, as you mentioned, scale a certain, if you have certain devices that are sending a lot of data to a service, then you can have multiple copies of that service so that it can scale to support the data load that is coming from those devices.
Okay.
And this is actually coming from this style of architecture was initially popularized by companies like Netflix and Amazon.
Mm-hmm.
For example, there is, as per the textbook definition, microservices are deployed independently. So that means there is a lot more containers that will be running because each microservice will be in its own independent container. And then another facet of microservices is that they don't communicate with each other directly because that creates coupling and that reduces the agility. So the idea is that the microservices will communicate using a messaging layer. And then the final idea is that the microservices will own their data. So essentially, if a microservice is working with a particular data, then they will have a data store that is allocated to microservices. Now, from a conceptual standpoint, this makes a lot of sense. And actually, it makes a lot of sense to develop some applications like the Netflix application, which is their main customer service application. It's also their main revenue generating application. And so it makes sense to develop a highly scalable application using microservices technology. But when you then apply this concept to, let's say, enterprise apps or even IoT apps that are being developed, you need to make some changes to it, because if you go full blown into microservices, then you would realize that you will have a lot of moving parts and pieces.
Mm-hmm.
And if you have independent data stores, then you would have a data consistency problem. And of course, if there is an error within a microservice, then how can you debug that? Because that error could be caused because there are errors in the other microservices that are sending or calling out this microservice.
Mm-hmm.
So I think adopting microservices blindly is something that I would caution against.
Mm-hmm.
What we are seeing, our customers are adopting what I call as a mini service architecture, and this term is became popular because Gartner started using it. But what we are seeing is that a real time use of microservices architecture for IoT applications has to be different than a traditional microservices architecture.
Okay.
And that's what we are seeing within our customer base.
And this would just be like a managing layer or something.
Yeah, so what this means is that instead of just blindly adopting microservices architecture, you could build mini services which are slightly more coarse grained than a microservice. And you can put these mini services together in a single container as opposed to deploying them in different containers. And that way you can reduce your
Okay.
operating footprint. And
Mhm.
the ultimate goal is to strike a fine balance between agility, scalability, and the need to manage a large number of moving parts like containers. So that's what you need to use some common sense and need to use a combination of both microservice architecture as well as mini service architecture to build your application.
Okay. Before we finish, I want to talk a little bit about machine learning. Earlier in the show, we talked about predictive applications, and you mentioned you can use a machine learning algorithm to help with this. What would you say the role of machine learning is in an IoT application?
So there is a lot of data that is flowing through because of the nature of an IoT application. And you can apply simpler rules, but then machine learning provides the next set of predictive rules that can be applied. And within the Software AG's Cumulosity IoT platform, we provide Zementis, which is our solution for hosting these machine learning algorithms. So independent of how the machine learning algorithm is built, you can build it using an R statistical language or you can build it using Python. It doesn't matter how you build it, but you can actually plug that within the Zementis engine, and that way it becomes available in our real-time data processing layer as well as within the batch analytics layer, so that it can be used to provide predictive analytics on the data that is flowing through the IoT devices.
Well, Sachin, thank you for coming on the show. It's been very interesting learning from you about building IoT applications and its architecture.
Yeah, thanks, Edaena, for inviting me, and I enjoyed this interview.
For Software Engineering Radio, this is Edaena Salinas.
Don't let security checks be a burden on your software deployment. Veracode Greenlight gives you secure coding feedback in seconds directly in your IDE. Try Veracode Greenlight for Eclipse free for 30 days and tap into Veracode's binary static analysis engine, delivering in-depth and accurate results to developers in just seconds. Request your trial of Greenlight for Eclipse today by visiting veracode.com/greenlight-trial. Not using Eclipse? Visit veracode.com/greenlight for information on Visual Studio and IntelliJ plugins. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.